Hello. I'll let you do the check-in screen on your own. How you feeling this week? Today's date, as always, is today. This is our 5th lesson in this unit, so I'm calling this 3-5. Today we are going to start talking about logarithmic functions. We're going to define and apply logarithms. Well, there are some basic things that you need to know. First of all, logarithms and exponentials are inverses of each other, kind of like how add and subtract undo each other. Exponents and logarithms can undo each other. You can rewrite any log as an exponential and any exponential as a log. So if I read this as log base A of x equals y, that's the same thing as saying a to the y equals x. You may see this lots of different ways. Sometimes instead of an a, they use a b. Sometimes they use different letters than x and y, but it's the same thing. The base of the log and the base of the exponent are going to be the same. The x is what it's equal to for the exponent, and the y is your exponent. So the log always equals the exponent. Example, log base 2 of 8 equals 3 is the same thing as 2 to the third equals 8. And you want to read that as log base 2 of 8. If you say log 2, 8, nobody's going to know what you're talking about. And you want to make sure that everybody understands you. Alright, common log. Common log has a base of 10. And we don't write that base. If you don't see anything written, it's understood to be a common log. And the base is 10, and what they're trying to get you to realize here is the base of the log and the base of the exponent cancel each other out. So that exponent is 1, so log base 10 of 10 is 1. Here, that can be rewritten as 10 squared. It's going to be 2. That's 10 cubed. So log base 1,000 is 3. And log base 10,000 is the same as 10 to the 4th. That is 4. Sometimes in science, if you have a huge range from something very small to something incredibly large, they will graph using a logarithmic scale. Doesn't happen very often, but it does happen. Alright, so we're going to write each of these equations in log form. So I'm just going to start by writing log. My base is 9, and I want to make sure that my 9 is small and subscript of 81 equals 2. What you don't want to do is write log 981. Okay? If you do that, that's going to be wrong. Make sure that it's a small subscript. This one is going to be log, and my base is 4 of 1024, or 1024. That equals 5. Now this one throws people off sometimes because it's got fractions and a negative exponent. It's going to happen. It's just going to be log base 1/3 of 9 equals -2. And our last one, log base 2 of 512 equals 9. Alright, now we're going to evaluate. I think this is where the real fun comes from. We need to know what that equals. Well, your calculator will do a common log and a natural log. On this, the base is 4. Your calculator is not going to do that. There's a couple ways around it. I'm going to show you the first one. I'm going to set that equal to x because I want to know what it equals. Then I'm going to rewrite that in exponential. The base is 4, so 4 to the x equals 32. Then I look, or I think back to my previous lessons. If I can get them in the same base, I can set my exponents the same. Well, 4 can be rewritten as 2 squared, and 32 is the same thing as 2 to the 5th. Well, now I have the same base, so 2x equals 5. X is 5 over 2. So if I were to evaluate that, I get 5 over 2. I'm going to do the same thing for the next one. I'm going to just set it equal to x. I'm going to rewrite that. 2 to the x equals 128. And sometimes it helps to know your powers of 2's. You might want to make a little cheat sheet and have those out. 2 to the x. 128 is the same thing as 2 to the 7th. So in this case, x is 7. We'll do a few more on this one. Set it equal to x. So 9 to the x equals 27. Well, I can rewrite 9 as 3 squared and 27 as 3 cubed. So I'd have 2x equals 3, or x equals 3 over 2. On the next one, I'm going to go ahead and do that one right over here. Set it equal to x. If I write that, 2 to the x equals negative 32, I think to myself, well, 2 to any power is going to give me a positive outcome. My range has to be positive. My range is going to be above 0. My domain is all real numbers, but my range is y is greater than 0. So that's not going to work. That one is going to be undefined or no solution. What they want you to get out of this is that you can never take a log of a negative number. And if you put it in your calculator, even if you use common base, it is going to come out undefined. Our last one, I'll set that equal to x. One-third to the x equals 1/9. You need to know that 1/3 is 3 to the negative 1. And we've talked about some negative exponents. You're just moving that 3 to the numerator, and when it moves, the sign of the exponent changes. 1/9 is 1 over 3 squared, which would be 3 to the negative 2. So I can rewrite that instead of, oops, let's go back to green. So instead of 1/3 to the x, it's going to be 3 to the negative 1 x. And instead of 1/9, 3 to the negative 2, so negative 1x equals negative 2, x equals 2. All right, this is just like the common log, but this is a natural log. Your calculator will do that. We've talked about the number e, and if I had a log and its base was e, which remember is 2.718, that's what a natural log is. So natural log is log base e. We use ln, and we're not going to ever really write down what the base is. It's just understood that the base on all of those is e. And again, what they're trying to get you to realize here is the base of the natural log and the base of the exponent, or the power, cancel out, and the answer is the exponent. okay? But just know, natural log, base E. So, in class I had everybody kind of do these on their own. I would set that equal to x, so 2 to the x equals 32. 32 can be rewritten as 2 to the 5th. So the answer there is 5. Set that equal to x, so 5 to the x equals 125. 5 to the x equals 5 to the third. X is 3. That's just a log, common log. Just count the zeros. All right, I will let you tell me how you're feeling about logs. Enjoy.